Hello, class. Continuing in section 3.3, we are now going to talk about what we are defining as local maximums and local minimums. And then we're going to talk about absolute maxes and absolute mins. So the idea of a local max and local min has a specific definition in math. And the idea is tied to our last concept of increasing and decreasing functions. And so here's the fancy definition of local maxes and local mins. The way I like to think about it is what I've written down here at the bottom of this slide. That a local maximum occurs when the graph changes from increasing to decreasing. And a local min is when the graph changes state from decreasing, going down, up to increasing. So what do we mean when we look at a graph? So if you look at this example that I have up here on the slide, you could see that point C1. So we're coming down, so we're decreasing, right? And then when we get to C1, we change state and start going up and decreasing. And that would be what we would call a local min. So it looks like a U, right? And it has to be smooth. And then when we're going up here, it's increasing. And then we get to point C2, and then we change state and come back down again. That also is going to be a local max in this case, because that's where we change state. And then C3 does the same thing where we go down and then back up again. And that means that's a local min. So you'll see one of the things that we don't learn in algebra is how to calculate these local min and maxes. You're going to learn that in calculus. We're going to focus a lot on calculating intercepts, especially when we get to chapter 5. But the idea is that this is the one thing on a graph that you won't learn to calculate until you get to calculus. But we want to introduce the concept so you're ready for calculus when you get in there, right? And so this is the graph that we're going to do as an example. And with regards to this, I sketched it on this on my whiteboard here, so I could walk through this and answer questions. But again, I'm going to upload this presentation so you could take a look at the pretty one as well and kind of go back and forth with regards to this. So I've marked the most important points with regards to this. So what is a local max? So a local max occurs when you increase, so you're coming up here, and then you decrease. So you could see that point number one, x equals 1, y equals 2 is a local max. And then these two are local mins. We're decreasing down to -1, and then we turn and start increasing again. So the local mins will be -1 and 1. And down here, it would be 3 and 0. I always like to use this opportunity to talk about range and domain. Super important concept. So what's a domain? Well, here it's all real numbers, right? Because this means we're going to the left to minus infinity, and this arrow means we're going to the right, positive infinity. So it looks like minus infinity, positive infinity. The range, a little bit trickier, right? I always find the range a little trickier. So what's the smallest value of y? Well, it looks like it would be y equals 0 right here at our x-intercept, right? So, and it's a bracket because it's included. But both these mean we're going up, right? And up means the positive infinity. So this would be positive infinity. So to continue with the maximum and minimum discussion, let's now move to absolute maxes and mins. And what we mean by the difference between absolute and maximum is this idea of, hit the wrong button there, is that it needs to be the biggest value of y would be the absolute max, and the smallest value of y would be the absolute min. So in this case, if you look at this figure that I have up here, you could see that the v is where the absolute min would be. And you could also see that that would be a local minimum, right? Because it changes state from down, increasing to decreasing. Up here, the u would be the absolute maximum because it's the highest value of y, but it's also a local because it goes up or increasing and then it comes back down and decreases. So sometimes you won't have a absolute max or absolute min depending on what the graph looks like. And so let's go back to the original graph that we had up here, right? And here was this aspect of local mins and local maxes. Whoops, that should be a max. Sorry about that. That'd be a local max. So with regards to an absolute min, that one I think would be the easier one. Because what's the smallest value of y? You could see the smallest value of y is y equals 0. So the absolute min occurs at x equals 3, y equals 0. So then the next question is, what's the absolute max? Well, you can see we have two local maxes, but neither one is the biggest y value, right? Because you could see that the y goes up on both sides from positive infinity on both sides. So when that happens, we typically say there's no absolute max, or sometimes we would just say y would go to infinity with regard to that. So that is the end of the discussion of local and absolute max and mins. And our last subject matter will be discussed in the next recorded lecture, and I believe it's average rate of change.